In this video lecture, we shall see how to draw the schematic and the stick diagram for a 3-input NOR gate. So the expression is y is equal to a plus b plus c whole power. The schematic is as shown. Okay, so the three NMOSs are connected in parallel, whereas PMOS is connected in series, and the output pi is taken. Okay, we shall now draw the stick diagram for this. So as you can see, I have already drawn the VDD and VSS rail, and I have placed a demarcation line here. Fine. Then I have the three transistors, or the 6 transistors, 3 PMOS and 3 NMOS. Okay. Now coming to this connection, so this is connected to VDD. So I will take a PMOS type and connect it to VDD, and I have to show a connection there. So that's it. Then this is shorted, so you can short this directly, this to this and this to this, and from C, okay, you will be taking the output. Similarly here, so for the same connection A, you can extend this A, this will be B, and this will be C. Fine. Now the next is we have to short all the sources and connect it to the VSS rail, and you have to short all the VDDs and you have to connect it to the output. Okay. Now what is important here is you should see that while making the connections, the poly should not cross the diffusion again, or else it will form one more transistor. Okay, I will show you what is that problem first, then we shall proceed. Okay, suppose if we connect like this. Okay, so this is the source. If you treat and you connect to the metal, one here and one here. Okay, so the thickness doesn't matter in the stick diagram. Okay, now and afterwards we'll place a junction dot here. So it means all these three sources are connected to the VSS. Now I want to connect the VDD. I have to short the drain now. How will I short? So the drains are here. Okay, and you can consider anyone as source and anyone as drain. Okay, so in this case, easier would be this. If I consider this side as source and this side as drain, and this as drain and this as source, so I can easily short this drain and drain. Okay, then afterwards I can consider any one of this source and any one of this as drain. So if you consider this as source now, okay, now this drain, okay, I will write you for this, for only for this problem. Suppose, so this side was source, okay, and this side was drain. Fine. So now for the second transistor, I have considered this as drain and this as source. Now I have to, and I have now considered this as source. Now this drain, I have to short it. Okay, so if I want to short it, so if I do something like this, okay, I can extend the diffusion anywhere, and if I do something like this, will it be correct? This is what I was saying. This will be wrong, right? Because when a diffusion crosses a poly or vice versa, it forms one more transistor. So this is wrong. Okay. Now the second option is that you short like this. But again, what happens here? Already the source is connected to the ground here. So if one more diffusion path crosses, then drain and source will be shorted. So that's why you have to arrange, or you have to think before you establish the connections, and you should make sure that your poly is not crossing the diffusion again and forming one more transistor. Okay, now for that what can be done is, okay, so what I will do is I will connect the source by using the metal. Okay, so I will take this source, fine, and I will connect it to the metal. So where is the junction dot needed now? The junction dot is needed here. Here it is not needed because it is already metal. So I will take, it's not junction dot actually, I am speaking, it is the contact. Okay, that's the contact. So all the sources are shorted now. Yes, all the sources are shorted. Now what is the advantage of this? You will see now. Okay, now the next job is to short the drains, right? Now I can extend this. Okay, I can extend this very easily. I can extend this drain here. Okay, now I need to short this, so I will short this, all these drains, fine. Now will this, let us see, will this will create any problem? It will not create any problem because these are two different layers and I am not showing a contact here. Only if I show a contact, then the metal and the diffusion are connected. Okay, now since I am not showing anything, so there is no contact here. So that's how I shorted all the drains. Now I need to take the output. So I will take the metal again. So I will connect to the C. I will connect. Since these are different layers, I will take contact. Okay, fine. Then you can take a poly and take the output. Okay. And you can show the contact again. Fine. So this will be your output Y. These are your inputs A, B, and C. Now can you see the poly is not crossing the diffusion again. So there is one, the first PMOS A, PMOS B, PMOS C, and this is NMOS A, NMOS B, and NMOS C. Then you can place a connection for the substrate and the PMOS as usual. Okay. So this is for the substrate and this is for the PMOS. Okay, where you take out the metal connection. Okay. So this is the stick diagram for 3 input NOR gate. Okay. Now what you have to do quickly is, similarly you draw the schematic for 3 input NAND gate and also draw the stick diagram. And for this you can also draw the mask layout. Okay, you draw the mask layout. Okay, so these two things are for the class assignment for you. So as soon as you see this video, you do this so that you are familiar. Okay, thank you.